Alright, another day, another chapter. CCNA number 2, chapter 5, inter-VLAN routing. We have studied routing concepts and kind of know how routers route. Now, if you don't, build a router in Packet Tracer and figure it out, or go back to that last chapter. And then also, before that, we were talking about VLANs. Okay, and so VLANs segmented each other. We need a router to route between them, or we need some kind of layer 3 device. And so that's called inter-VLAN routing. We separated groups, now we want to connect them through a layer 3 device, right? And routers route between networks. Each VLAN is a different network. So that's what we're going to be talking about today. We're going to do legacy, router on a stick, and layer 3 switching, which is always kind of scary. Describe the 3 primary options for enabling inter-VLAN routing. Okay, configure legacy inter-VLAN routing, configure router on a stick inter-VLAN routing, troubleshoot common inter-VLAN configuration issues, troubleshoot common IP addressing issues in an inter-VLAN routed environment, configure inter-VLAN routing using layer 3 switching, configure inter-VLAN routing in a layer 3 switched environment. So a lot of layer 3 switches going on. Gonna be a good time. Alright, what is inter-VLAN routing? Well, I kind of just explained it to you. We have our VLAN over here, right? VLAN 30. And so if we took out these router links, could PC1 get to PC2? So PC1 is in VLAN 10, and I guess it's PC3. Where's PC2 at? And PC3 is in VLAN 30. Could they get to each other without a router? No, they can't, because of that VLAN tag. And so different networks to connect them, we could do like this, which we kind of explained on. Well, never mind. Going too far, but. So this port, F01, F011, both in VLAN 10. So if we connect router 1 with the default gateway for 172.17.10.21, the network that PC1 is in, then PC1 could get to this other one. If we, did the same thing for here, if we put both of these in VLAN 30, F02 in VLAN 30, and then put F01 on this router as the default gateway for that PC, they could then get to each other. Otherwise, they are completely contained, and we kind of wanted that at one time for security. As you guys probably can see, not very efficient with ports, and here's a hint, we might be seeing trunking again, because remember, trunking keeps us from having to have a different port for every VLAN. And so here it is, legacy inter-VLAN routing, where we're just connecting switches from different VLANs. So it tells you what's going on, but basically there's 2 different VLANs, and so their default gateways are going to reside at this router and route between the 2. What's wrong with legacy inter-VLAN routing? We're wasting a lot of ports, kind of like I hinted at in the last slide. Okay. So, from then we went to another type of routing, and this is called router on a stick. And so what we decided to do is, remember, before they had 2 drawn, okay? Now, we're going to trunk this. Remember, we're going to set this with a native VLAN, and the trunk allows multiple VLANs to cross across this one link, one wire. And so how we're doing that is, once again, remember 80, that's a 802.1q, right? Or .1q for short. That is what we're going to trunk with on these routers as well. So we're going to have to set up a native VLAN for them and force them to trunk, and yep, all of that fun stuff. But before we figure out how to do that, or I think, yeah, we can figure it down here lower. we have our final way that we are going to learn to do this, which is multi-layer switch inter-VLAN routing. Okay, so now we're getting a switch that's a multi-layer, meaning that it can do more than just layer 2, it can do layer 3, so it'll take the job of a router. In our SVI, which I know you guys all remember, that's how we remote manage a switch. It now can take on a new function of where it will be a layer 3 port. It'll actually become the default gateways of these VLANs, at least it can. And we can also make on these switches, we can make this, we can actually, the multi-layer, we can make that layer 3 to this router. It's called a routed port because it works just like a routed port where we put an IP address on a physical interface. With the SVI, the IP address of the default gateway is actually virtual, as you know, because SVI stands for switching virtual interface, right? Okay, so activity, have fun identifying the different types. Okay, so now we go to configure legacy inter-VLAN routing. So what we're going to do, I'm actually not going to do this one. I will do the other ones, but all we're doing is putting an IP address. So on the router, we assign an IP address that is in the same network as the VLAN, and then we put the switch ports in that same VLAN. So if this is VLAN 30, we put this side right here into VLAN 30, give it an IP address for that network. If this is VLAN 10, we put it into VLAN 10, give an IP address for that, and it will work as long as you have your trunk set up, right? Because we need multiple VLANs to pass on there, and have these guys in the right network, and also have this port assigned for VLAN 10 and this port assigned for VLAN 30. Okay, so that is all you do to set that up. Why am I not going to have you do it? Because it's dead. We don't do it this way anymore. It wastes interface. We don't have that many on a router as there is. Also, if you were confused about what I said, here is the router. If you do want me to do it, send me an email and I'll make you a quick video on how to do this. But we're going to go straight to router on a stick. Read through those on the legacy, but it's pretty much just like setting up a router. Except you're putting on different VLANs. So to configure VLAN routing on a stick, where is my friend the packet tracer? Alright, here we go. I'm going to do this from scratch. I've just pulled the devices in. In fact, you can see Spanning Tree hasn't even finished on these computers. So what are we going to do first? Well, I am going to put, we're going to say this is VLAN 10, this is VLAN 20, VLAN 10, VLAN 20. So we're going to get this to work. So first thing I'm going to do is I'm going to get into my switch, and I'm going to name it switch 1. Oops. Alright, and so I'm going to make this switch, well, we're going to do a command called CDP neighbors, right? So we talked about it, probably shows CDP neighbors, and that shows me that my neighbor is the other switch, and he is on F01. And so I'm going to go into interface F01. I'm going to use some of the stuff we used from the switch chapter. And so first thing I'm going to say is dynamic, no. Am I trying to do switch port, mode, dynamic, desirable. Alright, so that's going to form a trunk for me. And then I'm going to go into VTP mode, or VTP name itti.net. Oops, not very good with commands today apparently. VTP domain itti.net. Alright, so now I've established a trunk because VLAN 1 is the default native VLAN, right? So now the two switches are trunking between each other, and so I am establishing VTP so that I can make multiple VLANs on by making them on one switch. So I'm going to make VLAN 10 by just saying VLAN 10 and saying name one group, and then I'm going to say VLAN 20 name 2 group. Alright, so now let's see if we were successful on our VTP by saying enable. First we're going to name this config T switch host switch 2 exit show VLANs, and we have 10 and 20. If you guys can see that there, I don't know if you can, but we have VLAN 10 and 20 made, so that worked out. So now what we're going to do is we're going to take this one, and it is an F02, and we said it was in VLAN 10, so I'm going to say conf-t interface F02 switch port access VLAN 10 switch port mode access, right? That takes that DTP into an access mode, can't form a trunk there, just a good best practice. Interface F03 switch port access VLAN 20 switch port mode access. Alright, so now I'm going to go back to my friends over here. Let's check what VLAN 10's in, and VLAN 10 is in F03, so I'm going to say exit interface F03 switch port mode access switch port access VLAN 10, and I think the other one is VLAN 4, but F04, but at least better safe than sorry. Okay, so we're going to do interface F04, and again we're going to do switch port access, oops, I put it in 10, switch port access 20, and switch port mode access. Okay, so I'm all good there for right now. What I'm going to do now is, so we have one in VLAN 10, I'm just going to use my favorite configuration. I'm going to say 192.168.10.2, right? VLAN 10, so I'm using 192.168.10.2. I'm going to make my default gateway 10.1, that's why I didn't use it. So we're going to set it like that. So that's in there. Now I'm going to go to the one in VLAN 20, 192.168.20.2, 192.168.20.1. Okay, this is VLAN 10, so we go 192.168.10.3, 192.168.10.1. Last computer 192.168.20.3, 192.168.20.1. Okay, so now we should be able to ping, because there is a trunk going, right, it's going to allow all the VLANs across here. Native VLAN is 1, so it's going to tag that as it goes across, or trunk link between switches, but I should be able to ping VLAN 10, right? So let's ping 192.168, wait, this is VLAN 20, so I can only ping VLAN 20.2. So what I'm looking for is, oh, it didn't even fail. I would expect the first one to fail as it never pinged there before. But we were successful, so I can get there, and what I'm going to do is I'm going to delete this link to show, right? So if we delete that trunk link, no way to get there, can't ping it. Alright, so now we put the link back in there, F01 to F01. Hopefully we have MDIX, we do, otherwise this would stay red, right? If these are 2950s without auto MDIX, we could not put a straight through on similar devices. Alright, so now we go into the router. And so when we do router on a stick, we actually do virtual interfaces, and this is G0, I believe, is what we said we plugged that into, G00, so let's check it, G00. Alright, so we're going to enable and config T. And so now we're going to go into interface G00, and you can turn this on, but most people don't. But what we're going to say is encapsulation. No, we're not. We just say no shut. We're just going to turn it on anyways because it makes me feel better. And then we're going to say interface G00 dot, and I'm going to do dot 10. Now this is just an identifier. I could do dot 1. It has nothing to do with the VLAN, but you do need a slash there. It has nothing to do with the VLAN, but I use it as the same as the VLAN. Why? Because then if we have a problem, we can look, hey, do we have this virtual interface? So we say interface G010. Alright, so now if I try to put an IP address, it would say I need an encapsulation. So I'm going to say encapsulation on this virtual interface. This is setting up, for VLAN 10, this will be its default gateway, but we say encapsulation .1q, and then we assign the VLAN. And so since I'm setting this up for 10, I say encapsulation .1q 10. 10 right there is what's going to associate with a VLAN. So encapsulation .1q 10, and then I say IP address, and maybe you remember my IP address was 192.168.10.1, 255.255.255.0. Okay, actually, before I do this, I better go back to 20 and show that I can't ping 10. Alright, so we could ping VLAN 10, but let's make sure we can't, or we can ping 20, but let's see if we can ping, nope, can't ping 10.1, fail, anyway, so exactly as we expected, because we need this router on a stick to work for inter VLAN routing. So we're back here. Alright, so we've went in the interface, turned it on, just went to, and notice on the physical interface, when we do a virtual interface, don't put an IP address on that physical one. It's going to mess everything up. And so now we're going to trunk it. So we set 10, set the IP address there. Now I'm going to say interface G00.20, which created that new virtual interface on here. And so we say encapsulation .1q 20. 20 is the VLAN. If we try to put an IP address before that encapsulation, once again, it would say must set encapsulation before you set the IP address. 192.168.20.1, 255.255.255.0. Okay, so we're good there. Now, what does a native VLAN need? Or, oops, what does a trunk link need? Well, you can guess from my mess up that it needs a native VLAN, right? It needs what it's going to tag on. Since we're already tagging on one, we'll just leave it with one. So now we say interface G00.1, alright, and then we say this one's going to be a little different. Encapsulation .1q 1 native at the end of it. .1q native, and no IP address. We're just going to, like, this is just going to be for tagging only. We're not putting any IP address on there, but instead of just saying encapsulation .1q and a number, we say native after that to make it the native VLAN. So now we set that up on the router. Now is it going to work? No, because maybe you said, hey, I didn't set this up on the switch, which is F02. So now I'm going to go into F02, interface F02, and I'm going to do switch port mode, trunk, and trunk it on that side, exit, right run. To save my interface, let's see, show interface trunk, and we want to see F02. Okay, F02 is trunking, and it's allowing VLANs across, which means as soon as we have spanning tree finished from where I pulled that, we should be able to ping between. So first things first, let's see if we can ping our default gateway. Ping 192.168.10.1. Oops, that's not our default gateway, that's the other one. So we know it's actually working. 20.1 is our default gateway. So now all computers can talk to each other, but what I would do first if it was me when I test this, so I test my default gateway, then I see if I can get to their default gateway, because if I can't get to their default gateway, there's no way I can go past their default gateway to them. But that's just me, whatever works for you. So let's try 10.2. Uh-oh. Now, okay, so it still worked. It timed out the first time. That's fine. What was it doing there? It had never found that, so it actually had to go out throughout the network and find it. Maybe you guys remember that if you go into simulation mode, you could actually see where those packets were going by auto capturing player, capturing forward, and using these packets down here. So feel free to do that. But that's it with setting those up. Go ahead and look back on those. I hope you guys can see this video. If not, you have the commands behind you. But yeah. Anyways, that's one of the things you're going to have to do. So what I did, I put another switch more than these guys. So if you didn't understand mine, try looking at what they are doing in these graphics here. But that should give you an explanation of what is happening. And they tell you to ping your trace route. Remember, trace route's just going to give you every path that it's going to jump. And so that was router on a stick, right? So just those virtual interfaces. Some downfalls of router on a stick is we only have one physical interface, right? So that gig port, the more VLANs we get, the more traffic that's going to go across there. So it's cheaper because we have to have less router interfaces, but our performance can only go so much. So that's why they came up with our next one, which is we're going to do inter-VLAN routing on a layer 3 switch, but apparently we're going through troubleshooting first. So some things that can happen that go wrong, right? Switch configuration issues. What they're showing here is you left this in VLAN 1. This is a legacy, so it should be in VLAN 10. Where these ports on the other side are in VLAN 30, right? So both of these should be in VLAN 10. If they're not, then this guy cannot get to the default gateway, and if you can't get to the default gateway, you can't go into any other network besides your own, right? Okay, so switch configuration number 2, router on a stick. They didn't trunk this interface, which is even worse than the last time. Remember, you need to trunk both sides for it to work. And then probably problem number 3 is forgetting. Okay, now they didn't trunk the connector switch, right? So anywhere we're passing multiple VLANs, make sure you trunk it. It's similar to switching issues. Similar issues you're going to have is just like anything you're doing trunking. Make sure your native VLAN's right here. The difference is, remember, if we're doing VLAN 1 as a native VLAN, which is not a good practice, but happens, that you still have to set it up on R1. It's not like we can do desirable on one side and auto on the other and pick it up like I did in the quick version there. Okay, so as we keep going, verify. How are we going to verify these? What are some troubleshooting commands when we're having issues? Show interfaces, interface ID and switch port. Remember, that's going to show us if we're trunking, our access mode, everything that has to do with those switch port modes. Show running config, as always, is probably my go-to. I'm going to do a show running if I'm ever having a problem and see if I can find it before I use the other commands, but whatever you want to do. But that looks like about all they are telling you there. So interface issues. How would we troubleshoot that we set in the wrong LAN? Well, if we go back, if you do that show VLAN command, it shows you that this F09 port would show that it was in VLAN 1. We could also show run, and like F011 would say that was in VLAN 10. F09 would not. Why? Because it doesn't say it's in a VLAN, but it's actually in VLAN 1. That's the default VLAN. Remember that. So it doesn't. Remember, switch ports aren't going to show your default settings. They expect you to know. Alright, so what are we going to do to verify router configurations? Show run, show interfaces. Pretty much the same. I'd probably go with show run. Alright, IP addressing issues, well, we have to know our subnet mask. We have to make sure our default gateway is in there. They're just, yeah, so I guess they're saying we haven't set up DHCP, so they're saying you're going to manually configure your IP address wrong. So as whenever you're doing something like this, make sure you are watching what IP addresses you assign. But this is pretty much common sense, I think. You can use showrun to see these, but you're still going to have to know that subnet math. But I know everybody loves it, and hey, if you can't remember it, I'd be happy to give you a worksheet on it. So send me an email if you need a subnetting activity, or use your lab book to find one, or the internet. There's plenty of them. There's always the application names. Alright, so introducing layer 3 switching. So as I've kind of said before, we're going to be talking about 2 ports. Alright, so this one going to the router is going to be a physical port with an IP address known as a routed port. Okay, so then our default gateway doesn't have anything to do with that. That is just going to work exactly like a router port. So now we're still going to trunk here, okay, and we're going to trunk probably here, in here, and everywhere that's hitting these switches, these layer 3 switches. And that's going to allow us to have redundancy in the default gateway and load balance. And what it's going to hit is our SVI. So it's going to actually hit the SVI, and the SVI is going to route once we put a command in. And that's what we're going to find. So I'm going to do this one as well. And so this is just showing you, what's happening. We've talked about it before in our design, but right, these distribution switches where the layer 3 switching is going to start happening happens at the distribution layer or the collapse core. It's still the distribution layer. So one or the other. The routed ports are probably this might be in layer 3 Ethernet bundle. These could be routed ports depending on what we're doing. It looks like they're setting it up because it says they have IP addresses. And apparently they did a layer 3 bundle here. So actually where our SVI hits is it's only going to hit if we have layer 3 happening in the access, or layer 2, I'm sorry. Layer 2 in the access, that's where we're going to have trunks, and they're going to go to the SVIs. Otherwise, we're just going to use all routed ports. But probably not concepts you have to focus on too much. But give me a second here, and I'm going to pull up a packet. Alright, so now we have this packet tracer over here. So mine's a little simpler than theirs. We're doing basically a collapse core. This is a small network. So when you want to get a multi-layer switch, if you go to your switch buttons, this is the symbol for them, right? 3560 has a layer 3 license on it. Alright, so now we got to do the same thing as we did. We're going to do a little bit different. Alright, so enable, and we're going to say dist for distribution 1. Oops. Config T dist 1. Alright. Need a host name for it. Host name dist 1. Alright, and we're going to go show CDP neighbors. Exit. Show CDP neighbors. And so show CDP neighbors, what I'm looking at is I'm going to set up interface F01, interface F01, and we're going to go switch port mode dynamic desire, and we're actually not going to trunk it yet. We're going to do a actual best practice. So we're going to say switch port, trunk, native VLAN, and 2. So we took it away from VLAN 1, and now we're going to go into F0. What was our other one? We can look at CDP neighbors, F02, and we say the same things. Switch port, trunk, native VLAN 2, switch port, dynamic desirable. Okay, so it's telling me here's a common error, CDP native mismatch, right? Because the other side is actually trying to trunk on VLAN 1. So now we go into here and we say same thing. Enable hostname dist2 conft man host dist2, and we're going to say show CDP neighbors. Actually, do show CDP neighbors. The do command, remember, just allows me to do privilege exec modes and config, and so I have F01 and F02 on here, so we're just going to do interface range F01, and we're going to do switch port mode dynamic desirable switch port mode. It's not going to let me do that, huh? What did I do wrong? Switch port mode. We'll just do trunk. Apparently it's not doing dynamic desirable on this side. Probably because I did the range command, so we're just going to do that. Okay, and so now we got an interface whose trunk encapsulation is auto, cannot be configured to trunk mode. What we're going to have to do is when we force trunk, this is on certain iOS's, we have to do switch port, trunk, encapsulation, .1q. Now we're going to do trunk mode, and we don't get that error. So we actually have to set the encapsulation. That means these switches can either do ISL, which is Cisco's old proprietary one, or .1q. So we actually have to set that. So did that. Then we do switch port, trunk, native VLAN 2. All right. So that should form a trunk right there. In here, we're going to enable and conf t host switch 2. This is the access switch. And I do show CDP neighbors. Only interface F0. We should have 2. Okay. What the heck? Switch is on. F03. And this is what? 01. Wonder why I skipped one. Okay, so we're going to say interface F01, which is the one that goes to the disk switch, and we're going to go switch port, trunk, native VLAN 2, exit, show trunk, because that should start trunking. Show interfaces trunk, and it's not. Why is that one not? Auto and trunk. Well, auto and trunk should formally, but they're not, so we're going to go F01 and do switch port mode trunk. Alright. Wait. Set F0. Well, let's see what's going on. So show run, we're getting a weird error. It says we're not trunking, so let's make sure F02. Oh, I only programmed one port. Okay, well that's our problem. Conf t interface F02 switch port trunk native VLAN 2, and since that one is on auto, it should now come up, and we should also see that CDP says it's fine now, but it's green there. Let's see if we get trunking yet. In the real world, it would tell you that this was corrected. It's not telling us on packet tracer. Show interface trunk. Okay. Another problem we could be having is I haven't created any of these VLANs. So we may have to VLAN 2. So this is why it was easier last time. So we'll see if that works. So show run. Yeah, we should be good there. Oh, so it's actually telling me that discovered on native F02 should be good now. Anyhow, show CDP neighbors, and we have CompT interface F03, and we are going to say switch port mode dynamic desirable native switch port trunk native VLAN 2, and it is still telling us that disk 2, this is not trunking. CompT interface F02 shut. No shut. Switch port mode trunk. Switch port native. Or switch port trunk encapsulation .1Q. I'm just going to hard set both sides to trunk because this would probably work in the real world, but it's having issues right now. Let's see, next one. We have enable host switch 1 P switch host switch 1 do show CDP neighbors interface F02 switch port trunk native VLAN 2 interface F01 switch port trunk native VLAN 2 exit VLAN 2. We're just going to create VLAN 2. All we have to do is type that. We don't even have to name it. And it should create it. And now I'm going to create VLAN 2 over here. CompT VLAN 2. I think I already created it there. CompT VLAN 2. And it says we have a native mismatch with switch F01, but we don't even have a switch F01 anymore. So switch 1 F01 is on VLAN 1 and we're on VLAN 2. See if it can get that figured out. Show run. I think we're okay. Okay, so now the rest of my VLANs I'm going to create like this. BTP domain itti.net VLAN 10 name 1 VLAN 30 name 3. Okay, so there we go. Still switch 1. These are grumpy little switches. We're going to take interface. I can see that it's actually native VLAN is the right one, so we're just going to take F0 1 shut, no shut. See if our packet tracer will start behaving. This is the one bad thing, right? Is sometimes packet tracer is weird, and right now it is being weird. So let's see, show VLAN, and we did get VLAN 10 and 30. So VTP, it was trunking through here, so VTP still gave us our VLANs. Great. So now we can move on. Alright, so what we are going to do is we could make redundant VLANs. I'm going to keep actually this disk switch into VLAN 2. We could do HSRP on this and have redundant default gateways where they could load balance, but the thing is if this failed, it would still fail. So we're not going to do HSRP today, so we're just going to keep this in layer 2. It'll be complicated enough for you guys. Interface F02 shut, no shut. Alright, we're still having an error, so apparently we're going to just try putting that into a straight trunking mode. Apparently it does not like 01 switch port mode trunk. Doesn't like that auto with anything. It's not doing the right native VLAN on that side. Anyway, so that should be good. So now I'm going to find out where our router is plugged in at, and we're G0 on the router. We're F03 here. So actually, no, we'll get inter VLAN routing running first. So we make it 2 SVIs now. So we say interface VLAN 10. Actually, we go back, exit, and we say we're in global config T. This is a must if you're going to have a layer 3 switch. You have to issue this command, IP routing. That allows for IP routing. IP version 6 routing if we're going to do IP version 6. So we issued that. So now we can do interface VLAN 10. That command right there is what takes it from being just a management port to an actual default gateway. Interface VLAN 10. So now we can say IP address like we always could, and we're going to do 192.168.10.1 255.255.255.0. Alright, and then we're going to go interface VLAN 30, and we say IP address 192.168.30.1 255.255.255.0. Maybe you guys noticed that as soon as I made these, the VLAN came up. If yours didn't, you probably haven't created the VLAN yet. So if you don't have at least the trunk formed where multiple VLANs are going across, this SVI cannot come up if it doesn't have an active port in some VLAN. And now that could be a trunk port just passing along and it will work. But you have to have at least one port active for an SVI to be active, and that goes for just a standard layer 2 SVI as well. So anyways, now we just made the default gateways for those. Okay, so now we're going to go down to our friendly switches down here, and PC0 I'm going to put it in VLAN 10. VLAN 10, so I believe that was F03, so we're going to go interface F03. What command we're going to type? Well, you probably guessed it, switch port access VLAN 10, switch port mode access, and then we're going to try interface F04 for the other one, switch port access VLAN 30, switch port mode access. And I can tell that that was right because the spanning tree changed on it. Now we're going to go into, oh wow, switch 1, 03. Switch 1 has a native mismatch with F02. We're just going to leave it and see if we have enough trunking with our redundancy, but now we'll get it. Let's see, F02, interface F02, switchport native VLAN 2, switchboard mode trunk. Alright, for whatever reason it's not liking that. Okay, so now we're back, and let's find out. We have F04, we're going to do F04 in VLAN 10. VLAN 10. So our high computers are in VLAN 10 and our low computers are in VLAN 30. Alright. So we're there. And so we say interface F04, interface 04, switchport access VLAN 10, interface F03, switchport access VLAN 30, switchport mode access. Alright, so now should we be able to talk amongst the VLANs with this router interface down? That was a trick question, because the answer is yes. Now why? Because the SVIs are going to be our layer 3. This is where all of our routing is going to occur when we program our computers for that. So that's our next step. VLAN 10, we already saw what our network's going to be, and so we say desktop IP configuration 192.168.10.2. 192.168.10.1 was my default gateway. We're going to go 192.168.30.2 and 192.168.30.1. Alright, and over here, this bottom one is a 30, so we go 192.168.30.23, or these two, 192.168.30.1, and finally this top guy, desktop. Uh, 192.168.10.3, 192.168.10.1. Alright, let's see if we set this up right. So I'm going to ping that SVI 192.168 10.1, and I can hit my default gateway. Can I hit their default gateway 30.1? I can. So I know already that I can get to their computers as long as the VLANs are set up. If I can get to the default gateway, it means that the switches, the access switches, are set up wrong. So I'm going to try 30.2. Uh-oh. And now this could be just, we've never pinged there before, so the first one failing's fine. In fact, even the second one. Now if we get to the third one, we know we did something wrong. Ouch, crash and burn. And so, let's see. We're in 10, so we'll try to get across the switch, see if we can do that. 10.2. We can get 10.2, which is over there, but we can't get 30.2, huh? Alright, so we're going to go to 30.2, we're going to unplug it, we're going to plug it into 4 and make sure that it is in the right VLAN. Show VLAN. Okay, so if sorry, my screen is not big enough for that, so we go to 30, and F04 is in fact in 30. So now we do a show we have another problem going on here. F03 is in, I don't know. Alright, my packet tracer is fairly wonky today. So we're going to show interface trunk, and it's telling us that 30 is allowed to pass on there. So what I'm going to do next is I'm going to go into this computer and let's see if we can hit our default gateway 30.1. And we cannot. Doesn't look like. So that's our problem. So how are we going to figure this out? Well, we're going to make sure this isn't a strange packet tracer problem. So we're going to actually ping from our default gateway 192.168.30.1. We're going to ping 30.2. And if it can ping, sometimes packet tracer gets messed up and it can't ping there. Wow. But we can hit 30.3. Now that doesn't make much sense, does it? Because 30.3, oh, I guess we didn't try 30, so let's see if we thought this guy was 30, but it's not. Well, exciting stuff. We're actually going to go into simulation mode because this is the easiest way to figure that out, and we're going to see what it is that we aren't able to do, and it probably has something to do with this last So we got an ARP request, but the ICMP failed. Okay, so next thing we're gonna do, back in real time. And so what are we gonna do? Pull this over here. 30.1. Show interface trunk. And our F02 for some reason is not allowing VLAN 30 to go across. That must be a reason, which it should go long enough that it finds it as, well, we have redundant links, but it's not. And so F02 is our closest neighbor to that 30. So what we're going to check is make sure we have VLAN 30. Maybe show VLAN. And we do have VLAN 30 on here. Sometimes if it's not trunking, the VLAN isn't created. Show VLAN up here. It should have 30. I believe we made it here. And it has 30. So we go conf t interface F01. We're just going to manually trunk this because we're having issues. Switch port mode trunk. Switch port native VLAN 2. And we're going into F01. And show run. If we look at F01, it says we are in trunk mode and on native VLAN 2, so we should be good to trunk there. Show VLAN, or show, we up and going yet? We're not quite up and going. Span tree still running. Show VLAN, show interface, trunk. It says we have nothing passing across. Okay, so now all of them are. So, try it again. Wow. Okay, so we have serious issues. So we go back to our simulation mode. Let's find out where they're failing. Actually, can't see the delete on here, so I have to do it the old-fashioned. So the arc turns. Alright, I'm just going to test this out, see if we have a loop from the ARP never returning. And we say ping. And there it started pinging. So even though it would work in the real world, apparently Packet Tracer was forming a loop and we're good to go now. So 10.1, we can ping it. 30.3. That or our trunks aren't working correctly. Hope you guys don't have this much problems. Anyways, we'll go back to the drawing board. And let's see if we're getting, let's see if we can trunk here, show interfaces, trunk. Alright, so 30 should be passing across all of these. Let's just eliminate this entire switch and see if we can get to 30 now. Well, 30 can't get to its default gateway. Let's see if 10 can. So they were working in the past, so that tells us that they actually were working through the other switch, and it's these two switches that can't communicate. So, show CDP neighbors, and the switch connected to, oh, it doesn't even show, does not even show switch 2 as, or switch 1 as a neighbor. So, what is going on there? F01. So throw it into F01. See if it works then. Alright, so we're getting a little bit of activity. Can they see it? Show CDP neighbor. Alright, so for whatever reason, that link went down. And we want F01, and so we want it to show, no, it's not F01, show CDP neighbors. Now we can see switch 1, and it's F0, what? Oh, this is switch 1. No, it's switch 2. Showing me connected to this one. Alright, show CDP neighbors. Okay, so F02. So we want show interfaces trunking. We want to see those going across F02, and we can. Ping 30.1. We'll let this time out, and now we're going to get straight into this switch. And so we would trace out this connection, timed out all of them. So we're saying F03 is VLAN 10, F04. Maybe I didn't have those plugged in the right ports, so show run. So we want F03 in VLAN 10 and F04 in VLAN. Now we have F03 doing other stuff. So we're gonna do, let's see if we can do this command. Config T D. It won't let us default this. So what we can do is we had F03 apparently connected to one of the trunking switches. So we're gonna go why are you not working? Oh, here we go. So we're going to go into F03, interface F03, and I'm going to do show run so I can see exactly what I want to take off. Do a control C so I can stop it right there. No switch port, trunk, native VLAN 2, even though it shouldn't matter. No switch port mode. Actually, it can be switch port mode access. So that's the only command we don't need. So VLAN 30 is F03. So let's see, is this F03? Nope, it was not in F03. So we're putting VLAN 10 into F04. This one into F03. So now VLAN 30 is in the right port. As soon as spanning tree happens, let's make sure F04 is VLAN 10. And normally this is not that hard. So, yep, F04. T interface F04. Switch port mode access. Alright. So we know it was trunking at the time. Ping 192.168.10.1. Alright, we can hit our default gateway. Hopefully we can hit 30.1. And we can, so we should be able to hit 30.2. Yep, how about 30.3? Oh no, the dreaded 30.3. And it did fail the first time, but worked. Thank goodness. Okay, so that is layer 3 switching through an SBI. So now we get to the fun part, as that wasn't fun enough and not taking enough time. So we go in, we go back to here, and we go into, we're going to go F01. It's plugged into G00, so we say conf T, and remember, you can't do this command if you didn't do IP routing. So this is making a routing port, and we say F01. And to make it a layer 3 port, we say no switch port, right? Switch port is all our layer 2 commands, so saying no switch port gives us layer 3 commands. At that point, we can say IP address 192.168 2.1 255.255.255.0. No shut. It's already turned on because it's a switch port, but you know, old habits die hard. So now that's a routed port. So now we just have to turn on the other side. No. Enable 192, and we say conf T interface G00. IP address 192.168.2.2, 255.255.255.0, exit. Okay, so now we should be able, no shut, I needed a no shutdown on there, comp T, rusty, interface G00, no shut. Alright, so now that's up. So now we're going to go in, we're going to make sure we can ping across there, so ping 192.168.2.1, and we can hit it. Alright, so that's pinging. So now, can this router talk to these computers down here? And the answer is no. And why is the answer no? Because it only knows it's directly connected, right? So this switch can ping all networks. It'll be able to ping everywhere. And so these computers will be able to go up here, but the router will fail because the router doesn't know how to get to them. All it knows is this 2-0 network between it and the routed port of the switch. So in this case, we could do a default route, or we could just do IP route 192.168.10.0, right? That's our network. 255.255.255.0. The next hop is 192.168.2.1, right? As part of the switch right here. That interface. That's how you get to there, except we need to be in config T, so we'll do it again. IP route 192.168.10.0, 255.255.255.0, 192.168.2.1. Then we go back and we can rewrite that because it's the same command for 30. Do that, and then if we had the internet out there, we could do a default route out the other direction, but we don't have anything out there right now. And so, let's see if we can have any more problems by pinging 192.168.10.1. And we can hit 10.1. And we can hit 30.1. So we should be able to hit 30.3, we can, and 30.2, and 10.2. Uh-oh. Yep, there it was, and 10.3. And we can ping everywhere in our network after we write those commands. So, sorry that took so long. Great learning experiences. Try it yourself. It is, I guarantee, I'm actually going to save that for when we go routing protocols. We're going to do some more stuff. I might set up some more layer 3 switching. But I suggest that you also make that, just to make sure that you understand that. So, what it's talking about here, right? SVI becomes your default gateway, like you guys saw. A routed port usually goes in between a router, but it could go all the way down to the access if we're doing layer 3 all the way down. But anyways, these are routed interfaces. Probably they'd be a routed ether channel, layer 3 ether channel. We can't do that with Packet Tracer, but you can do it in the real world. And then I showed you configuring static routes. Oh, here's a stupid question. On the 2960, you do show CDM prefer, and then you issue the command. Let's see. Yeah, this is a test question, but anyways, you do the show CDM prefer command. And it tells you if you can do land-based routing, which means you could do static routes on 2960Xs, I believe, or I guess if it's the right model of 2960 normal. So that allows version 4, and what it says right here, I think, is you need the IP version 6 unicast routing if you're doing IP version 6 routes in the same mechanism. So this is just if we don't, like, instead of doing default gateway and putting it, we actually can put a default route in 2960 with a land-based license. Configuration issues, trunks can be an issue, as you guys saw. Routing needs to be enabled, right? If you didn't do IP routing, it's not going to work. SVIs, the VLAN must be up. Host must be in the correct IP address and subnets. Your access switches need to be trunked right, which is probably what was happening to us in that little example. Anyways, So switchport access VLAN. What is it doing? I don't know. What are we doing here? It's a troubleshooting plan. Take a look at it. I have wasted enough of you guys' time with actually how to do it. So that's how we connect all these different, after we segment them, we connect them. And so later on we're going to start going over access lists where we block them again, right? So we put them together to block them to make them more secure, right? Just each part of it needs routing, and yeah, we can just do different things. I guess we could actually keep one blocked out, right? If we didn't give it a default gateway, it couldn't go anywhere. So besides to its own network. But anyways, that's inter-VLAN routing. If you have any questions or comments or anything, discussion boards, or send me an email.